Welcome to True Projects. In this video, we are going to explain about the project, which is bug detection based on LSTM networks and solution codes. Before diving into the project's execution, let me give you an overview of the project. Programming bugs are the errors or the flaws in software code that cause it to behave unexpectedly or produce incorrect results. These bugs can range from simple syntax errors such as missing semicolons or parentheses to more complex logical errors such as incorrect algorithmic implementation or unintended side effects. Identifying and fixing programming bugs is essential for ensuring the functionality, reliability, and security of software applications. The project addresses the challenge of identifying programming bugs within the source code efficiently. Programming bugs can range from syntax errors to logical inconsistencies, leading to software malfunctions and vulnerabilities. Detecting and resolving these bugs is crucial for ensuring software reliability, security, and performance. The primary objective of this project is to develop a robust bug detection system leveraging long short-term memory, which is LSTM networks. These networks are type of recurrent neural networks well suited for sequential data analysis, making them ideal for detecting patterns in software code. The project employs LSTM networks, a form of artificial neural network that is capable of learning long-term dependencies in sequential data. By training LSTM model on the dataset of labeled code snippets, with bugs identified, the system learns to recognize patterns indicative of bugs. This approach allows for automated bug detection, potentially reducing the manual effort required for code review and debugging. Beneficiaries of bug detection project using LSTM networks include software developers who can streamline debugging efforts, software quality assurance teams who can improve testing processes, and end users who benefit from more stable and reliable software products. To implement this project, we need software and hardware requirements. Coming to software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, front-end technologies of HTML, CSS, JavaScript, and Bootstrap 4. Coming to hardware requirements, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Algorithms which are used in the project for bug detection are LSTM, long short-term memory. It is a type of recurrent neural network architecture designed to overcome the limitations of traditional RNNs in capturing long-term dependencies in sequential data. It achieves this by introducing specialized memory cells with gating mechanisms that regulate the flow of information. LSTM is used in bug detection to analyze the code snippets and capture complex patterns indicative of bugs. Its ability to retain information over long sequences makes it well suited for tasks involving code analysis, where bugs will be deeply embedded within the code base. Coming to the next algorithm, which is LSTM, which is bidirectional long short-term memory, it extends the LSTM architecture by processing input sequences in both forward and backward directions simultaneously. This allows the network to capture information from both past and future contexts, enhancing its understanding of the input sequence. It is employed in bug detection to further improve the model's ability to capture contextual dependencies within the code snippets. By considering information from both directions, LSTM can potentially identify subtle patterns and correlations that is missed by unidirectional models. Coming to the next algorithm, which is LSTM with GRU, which is long short-term memory with gated recurrent unit. These are the two types of gated recurrent units, each designed to address the vanishing gradient problem in traditional RNNs. Combining LSTM and GRU architectures creates a hybrid model that leverages strengths of both approaches. The LSTM with GRU hybrid model is used in bug detection to exploit the complementary strengths of LSTM and GRU units. This combination can improve the model's ability to capture long-term dependencies while also enhancing computational efficiency. Coming to Transformer, it is a state-of-the-art neural network architecture introduced in the field of natural language processing. It relies on self-attention mechanisms to capture global dependencies in input sequences, eliminating need of recurrent connections. Transformers are used in bug detection to process code snippets and capture complex relationship between code elements. This self-attention mechanism enables them to capture long-range dependencies efficiently, making them suitable for tasks requiring analysis of large code bases. The next algorithm is MLP, which is multi-layer perceptron. It is a classic feed-forward neural network architecture consisting of multiple layers of neurons. Each neuron is one layer, connects to every neuron in the subsequent layers without forming any cycles. MLP is used in bug detection for feature extraction and also as a classifier to identify patterns indicative of bugs in code snippets. While simpler compared to recurrent architectures like LSTM, MLPs can still capture meaningful patterns in code data and contribute to bug detection tasks. The last algorithm is voting classifier. It is an ensemble learning technique that combines the predictions of multiple individual classifiers to make a final prediction. In the bug detection, a voting classifier is employed to integrate predictions from different models such as LSTM, BiLSTM, and the other algorithms. By leveraging the diversity of these models, the voting classifier can be more robust bug detection decisions, potentially improving overall detection accuracy. Now we will execute the project. To execute it, first we have to open the code folder which contains source code files. So this is the code folder of the project and this is the data set that we use for training. So in this data set, in this column, we have the code snippets and each paired with an error message in this particular C column. This specifies the types of error encountered such as index errors, name error. Similarly, we have 15 more error types. These error messages provide valuable context for understanding the bugs present in the code snippets. Analyzing this dataset allows us to study common programming errors and explore effective debugging techniques. So we can use this data to train the deep learning models and machine learning models and detect the bugs in the codes. So I'm closing the data. Here we have the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files. This is the template folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content that to be rendered in HTML templates. This is the model file which contains the algorithm information and that will be loaded into the project code during runtime. This is notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. This is the signup.db file. This file is a database file used to store the information. And here in this file, we have the test cases using which we'll be deploying the front end. So we have used all these codes for testing them in the front end. And we have different types of errors in it. So we will be using them for testing in the front end. Now we will copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now we need to open the Anaconda prompt. Using the cd command followed by the space, we need to paste the copied path and then click on enter. By this, we can see that current directory is changed to the code folder's path. And now we need to compile the file app.py. So I'm giving the command python space app.py. Now click on enter. This command will execute Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, Flash framework will host the application locally at the default address, which will be the local host and the port unless configured differently. So this is the local host and this 5000 is the port. Now we need to copy this local link provided by the framework and paste it in any web browser. So I'm copying the link. I prefer Google Chrome, so I'll paste it in that. Here we need to paste the link and then click on enter. This is the web page of the project, which is displayed in the browser and it is developed by using Flash framework. So to execute, first we need to sign up if we are the new users. So click on sign up and enter all the registration details if we are registering newly. I have already registered and I have an account in it, so I'll directly sign in. So click on sign in. Here we need to provide our credentials, which are the username and the password. So I'm giving my username and the password. Now click on login. We have logged in successfully and we are redirected to prediction page. So here we can see a text box wherein we need to give the input code snippet based on the given code. It will detect which type of bug is present in that particular code. As we have already told you that in the sample folder, we have the test cases which will be used for prediction. So I'm copying the first test case. I'm pasting it here. Now click on predict. So here, the application has predicted this particular code as index error, which means that the index error bug is present in this particular code. And the topic for the paragraph is most dependent upon these words. Now we will try giving the other code. I copied the code here in the text box. Now click on predict. Based on the provided code, here we got the bug detected as file not found error, which means that in this particular code, there is file not found error. Now we will try giving the other code. Click on prediction. I'm pasting the code here. Now click on predict. Here the error is detected as tab error in this particular code snippet. Now we will try giving the other code. Click on prediction. So I've given the code here. From the code, it has detected as there is a bug called key error. Now we will give other code. Click on prediction. So I have given the code here. Click on predict. The bug detected in the code is zero division error. We will give one more code. I have given the code. Based on the provided code, the bug detected in the code is module not found error. So now we will give one more code. I have pasted the code. The error detected is TLE error in this particular code. So the error to be rectified is TLE error. Now we will give one more code. So I'm pasting the code here. The bug detected is attribute error. So this particular error has to be rectified based on the attribute error. We will give some more test cases. Click on prediction. I have given the code. Now we will see what is the error is present in this code. So the error is EOFE error detected from this code. So I'm giving the code here. Click on predict. Here the error detected is value error. Now I will give some more test cases. So I've given the code here. Now click on predict. The error detected is indentation error. So this bug has to be resolved. Now we will try giving the other code. I have given the code here. Click on predict. The bug detected is type error. So we'll give some more codes. I have given the code snippet. Click on predict. Here the bug is detected as name error. Now we will give some more codes. I'm pasting the code here. Click on predict. Here we got the prediction as syntax error. So this has to be rectified. So now click on sign out. In this way, just by giving the code snippets to the system, it will detect which type of bug is present in that particular code. The project successfully employed a combination of the algorithms including LSTM, BiLSTM, LSTM with GRU, Transformer MLP, and voting classifier to detect and rectify bugs present in the provided code snippets. Through analysis, prevalent error types like index error, name error were identified, etc., guiding effective debugging techniques and offering significant insights for enhancing software development practices. Looking ahead, the project outcomes hold potential for refining bug detection methodologies and driving progress in software quality assurance.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.